In this video, I will go over the homework that follows the lecture 6.4 that focuses on using the L'Hopital's rule to resolve the indeterminate form that has the difference in it. And here's important to understand that we may not always be able to resolve the infinity minus infinity indeterminate form, and our only chance is to rewrite it using rewrite the expression in the limit or the function as a ratio. That's the only strategy we have. So let's see how it works on the homework. So here we have a limit of a function that has a difference of two other functions that evaluated at 0 both give you infinity. So this is infinity minus infinity. Now, what are we going to do here? Well, the only way I know to rewrite a difference of two fractions as a single fraction is to actually do the subtraction. So let's find the common denominator and let's perform the subtraction. And what we have now as a result is we have a lot of zeros. So we have a lot of zeros in the numerator, we have a lot of zeros in the denominator. So now it's just 0 over 0. And if it's 0 over 0, that means we can use the L'Hopital's rule. And we're going to differentiate it. So here we have 2 cosine 7x times 7 minus 3. And in the denominator, we have the product. So derivative of x is 1 times sine of 7x plus x times the derivative of sine of 7x, which is cosine of 7x times 7. And now if we plug in 0, we will see that the numerator becomes just 11, and denominator still remains as 0. So dividing 11 by, but it's a one-sided 0. It's just hard to tell if it's left or right. So this is negative, this is negative. It looks like it's going to be the negative 0. So when you divide a number by negative 0, you're going to end up with a negative infinity. So that's going to be my answer. And that's exactly how they did it. All right, next problem. Here we have a limit as x approaches to 5. We have two rational functions, and we know that two rational functions can always be added, subtracted, multiplied using pretty much the rules of the basic rules of math that allow you to perform addition, subtraction, multiplication of fractions. So in this case, if you plug in 5 into the denominators, you'll see how they're all 0. So we have infinity minus infinity. And now to resolve this, we're going to find the common denominator, meaning that we want to factor out everything. So in the first one, we have 3x minus 5, and it's going to be x minus 3. minus x over 3x minus 5. So I need to multiply this by x minus 3. Now we have common denominator. And we have 10 minus x squared plus 3x in the numerator. And in the denominator we have 3x minus 5 times x minus 3. So if we plug in 5 into the numerator, and here it's, well, instead of plugging things in, trying to, we can, if you plug in 5, it's 25 minus 25, so x minus 5, I guess, is a factor in the numerator, and we can factor it. So if you factor x minus 5, you're going to end up with x plus 2. And here we have also x minus 5. And as x approaches to 5 plus, after you reduce this, we have a continuous function. So the answer will be negative 5 plus 2 divided by 3 times 5 minus 3. So it's negative 7 over 6. Alternatively, we could have done L'Hopital's rule over here, and we would get the same answer. All right, we have another problem. We have infinity minus infinity. We can immediately reduce the 5 just to make the problem easier, right? We can also take 1/3 out. Why not? And now we see that as x approaches to 1, we still have infinity minus infinity, right? So we haven't done anything to resolve the issue yet. So we're going to now try to rewrite it as a fraction. And the only way is to do that is to actually perform the subtraction. So find the common denominator and do the subtraction. Now we have 0 over 0, and we're going to try to use the L'Hopital's rule. In the numerator we have derivative is 1 minus 1 over x. And in the denominator we have the product rule. So it's 1 over x times x minus 1 plus ln of x times the derivative of x minus 1, which is 1. Now what do we have? Now if we plug in 1, we still get the 0 over 0. Before using L'Hopital's rule again, I'm going to simplify it. So I'm going to multiply the numerator and the denominator by x. And hopefully that will resolve the issue. let's see. Applying L'Hopital's rule. Here we have, in the numerator we have 1. In the denominator we have 1 plus the derivative of this product. It's going to be ln x plus x times 1 over x. And it looks like the answer is simply 1/2 for the limit, so the overall answer is 1/6. And let's see. All right, let's go to the next problem. We have limit as x approaches to 0 of 1 over I'm going to do the same thing as I did before. I'm gonna take out 1 over 11. Not doing that will be a terrible mistake. And now we have the 0 in the denominator, so we have 1 over 0, which is infinity, minus another 1 over 0, which is another infinity. So to resolve this, we're going to do the subtraction. So it's going to be x minus e to the x plus 1. We're going to find the common denominator, which is the product of those denominators. And we have a lot of zeros in the numerator and the denominator, so we have 0 over 0. Now we can use L'Hopital's rule. And according to the L'Hopital's rule, it's going to be the derivative of the numerator divided by the derivative of the denominator. So here we may want to distribute x over. So instead of using the product rule on e to the x minus 1, we'll be using the product rule on x e to the x. Let me rewrite this. What I'm saying is we can distribute this x over this. Now it's much easier to differentiate. So we have minus 1 at the end, and now derivative of x is 1 e to the x plus x e to the x. So plugging in zeros still gives us 0 over 0. So we'll use the L'Hopital's rule again. This time the derivative of the numerator is just negative 1 over x. And the derivative of the denominator is e to the x plus e to the x, I'm doing the product rule, plus x e to the x. And now you can actually see how all this e to the x's cancel. So what we have left is simply 1, negative 1, over 1 plus 1, 2, and we have x over here. So the answer is negative 1/2 for the limit, but we also had that factor of 11. So the final answer is negative 1 over 22. All right, let's try next problem. Oh, we are done. If you have any other questions about using L'Hopital's rule to resolve the indeterminate form infinity minus infinity, please let me know.